In an earlier video, we looked at some theory behind the disk method, and in this video, we want to put that theory into practice. So we want to work through an example here. So what we're going to try to do is take a function square root of x. We're going to try to revolve this guy around the x-axis, and what that's going to do is it's going to create a solid as the function comes out towards us, and then down, and then behind the xy plane and back again. It's going to sketch out a three-dimensional solid here, and I'm trying to find the volume for this particular guy. And so let's recall what the disk method was. What was the formula that gave us the volume of a solid like this? Well, here it is. Is pi times the integral from a to b, and that's on your x-axis, assuming you're revolving it around the x-axis. It'd be different if it was the y-axis, of your function of x squared dx. And again, I need to note that this is only if you're talking about revolving this guy around the x-axis. We would integrate with respect to y if it was around the y-axis. If it was spun around the vertical axis, you'd get a totally different looking solid here if you revolve this pink line this way as opposed to the way we're doing it this way. Okay, but the way we have it, this is the correct formula to use, and it's pretty straightforward. Basically all we're doing is we're taking our square root function, sticking it in the disk method and computing this integral and multiplying our answer by pi. So as long as we can do all of those things, then we shouldn't have any trouble getting the answer here. All right, so I'll tell you what, just to save some space, let me copy this thing here. So copy that right there. Okay, let me hide all this stuff, make some more space. There we go. Okay, so here's our formula, and we're basically just going to plug in our information for this disk method here. So our volume would be pi times the integral from, and actually I need to go back, we need to see what these limits are. If you look here at our picture, what were our limits of integration? Was it 0 to 2 or was it 0 to 4? Well, being that we were integrating with respect to x, the x's vary from 0 to 4, not 0 to 2, but 0 to 4. Your disk, in other words, are stacked from left to right from 0 to 4. Okay, so we remember that there. Okay, so we'll go 0 to 4 of our function squared dx. Now, what was our function? Our function was the square root of x. So square that term there. We have pi times the integral from 0 to 4. The square root of x squared will just be x on the interval 0 to 4. Okay, so we can integrate that as a very easy integrable function. We would have x squared over 2 bracket with a 0 and a 4. And so our final answer, we would need to plug in 4 and plug in 0 and subtract these quantities. So let's see what that would give us. So our answer would be 4 squared is 16. 16 over 2 is 8. So we'd have 8 pi. And when we plug in 0, we get 0. So looks like our volume of that solid of revolution would be 8 pi. And you could approximate that by a decimal if we wanted to. So looking back at this picture, just to close out this video here, this guy here has a volume of 8 pi units of volume here.